The largest star that ever existed may not have been a star in the way we understand them. It may have been a contradiction, a star so enormous that millions of suns could fit inside its mass, a star so bright that entire galaxies could struggle to compete with it. And deep inside that impossible giant, something darker was already growing. A black hole. At first, the idea sounds impossible. How can a star contain the very thing that should destroy it? How can a black hole, a place where gravity wins completely, exist inside an object that is still shining? This is the kind of question that reveals something important about the universe. Nature does not always create simple things. Sometimes, the most extreme objects are born from opposing forces fighting each other. Gravity pulling inward, energy pushing outward, a battle that can last millions of years until one side wins. To understand these strange stars, we first need to understand ordinary stars. A star is not just a ball of fire floating in space. It is a balance. Every second of its life is a negotiation between two enormous forces. Gravity is always trying to compress the star. The combined weight of billions of tons of material is pushing everything toward the center. But deep inside the core, pressure and temperature become so extreme that atoms begin to fuse. Hydrogen becomes helium. Helium can become heavier elements. The process releases energy, and that energy pushes outward against gravity. For most stars, this balance creates stability. Gravity tries to destroy the star. Fusion tries to hold it together. And for a time, the universe finds equilibrium. But stars are not immortal. Eventually, the fuel that powers the core begins to disappear. A star like our Sun will eventually leave the main sequence, expand into a giant, and end its life as a white dwarf. But the largest stars follow a far more violent path. Their enormous gravity allows them to build heavier and heavier elements inside their cores: carbon, oxygen, silicon, until finally they create iron. And iron changes everything. Iron is not a new source of energy for a massive star. The star has reached the point where the furnace inside can no longer fight gravity. The balance collapses, and in a moment, a star that spent millions of years holding itself together begins to lose the battle. The core falls inward, not slowly, not gently. It collapses under the weight of an entire star. The outer layers follow. A tremendous explosion tears through space. A supernova is born. For a short moment, one dying star can shine with the power of billions of suns. The explosion throws newly created elements into the universe. The oxygen you breathe, the carbon in your body, the iron in your blood. Many of these atoms were created inside ancient stars that died before Earth existed. But sometimes the death of a massive star leaves behind something even stranger. A neutron star. Imagine taking the mass of a star and compressing it into a sphere only a few dozen kilometers wide. The atoms are no longer arranged in the familiar way. The pressure becomes so intense that electrons and protons are forced together, creating neutrons. Matter itself changes. The result is not a normal star anymore. It is almost a giant atomic nucleus. A cosmic object where a tiny amount of material can contain an unimaginable amount of mass. A teaspoon of neutron star matter would weigh billions of tons on Earth. The surface is solid. The interior may contain exotic states of matter that scientists are still trying to understand. Deep inside, the pressure may create strange structures known as nuclear pasta, not pasta made from food. Pasta made from the arrangement of atomic matter itself. Layers and shapes formed because the strongest forces in nature are competing at the smallest scales. But neutron stars are not the strangest possible outcome, because there is another possibility. A star so massive that even a neutron star cannot support it. A star where gravity does not stop. It wins completely. A black hole forms. Normally, this would be the end of the story. A star dies. A black hole is created. The remaining object begins its long existence hidden behind an event horizon. But the early universe may have created situations where the story became much stranger. A few 100 million years after the Big Bang, the universe was not the organized place we see today. There were no mature galaxies like the Milky Way, no familiar stars, no heavy elements filling space. The universe was younger, hotter, and filled mostly with hydrogen and helium. Gravity was working on enormous clouds of primitive gas. And in some regions, these clouds may have become unbelievably massive, much larger than the clouds that create ordinary stars today. In these extreme environments, something unusual could happen. Instead of forming a normal star, a gigantic object may have formed. A star far beyond anything we see in the modern universe. A supermassive star. These theoretical giants may have reached thousands or even millions of times the mass of the Sun. Their lives would have been completely different from ordinary stars. They would not have been peaceful. They would have been cosmic battles. Gravity would be crushing them inward with unimaginable force. Radiation from their interiors would fight back. The star would grow and grow, constantly trying to maintain a balance that was almost impossible. But eventually, even such a giant may have reached a limit. Its core could collapse. A black hole could be born. And this is where the universe creates something almost unbelievable. The black hole does not destroy the star immediately. Instead, the star survives around it. A black hole is born inside a star, a hidden heart of darkness surrounded by millions of suns of glowing gas. The object is no longer a normal star. It is a black hole star. The name sounds like science fiction, but the idea comes from a real scientific question. How did the first giant black holes in the universe become so massive so quickly? Astronomers have discovered extremely massive black holes from a time when the universe was still young. Their existence creates a problem. If black holes start small and grow slowly, how did some become monsters so early in cosmic history? Something may have given them a shortcut. Black hole stars are one possible answer. Instead of beginning with a tiny black hole that slowly eats its surroundings, imagine beginning with a black hole already surrounded by an enormous supply of gas. The food is already there. The environment is already extreme. The growth process has already been accelerated. The black hole inside the star begins feeding. Gas spirals inward. Matter heats up. Radiation increases. The object becomes a strange cosmic machine powered by the collision between two opposite forces. The black hole tries to consume everything. The star tries to remain alive. And for a brief moment in cosmic history, both succeed, but the balance cannot last forever. The black hole grows. The surrounding star changes. The interior becomes more violent. Eventually, the parasite and the host become impossible to separate. The black hole that helped create the giant star may eventually become the thing that destroys it. The star that gave birth to the monster becomes the monster's final meal. And when the star disappears, what remains is a much larger black hole, a seed, a beginning, a possible ancestor of the supermassive black holes that sit at the centers of galaxies today. The universe may have created its largest monsters by first creating stars that were never supposed to exist. And that raises the next question. If these impossible stars existed, what happened to them? The destruction of the black hole star would not simply end a strange chapter of cosmic history, it would begin another. Because hidden inside these impossible giants may have been the first seeds of the largest structures in the universe. The supermassive black holes sitting at the centers of galaxies today are among the most mysterious objects we know. They can contain millions or even billions of times the mass of the Sun. Yet some of these giants appear to have existed surprisingly early when the universe was still young. This creates a profound question. How did the universe build something so enormous so quickly? A normal stellar black hole begins with the death of a star. It may contain several times the mass of the Sun. Then it grows slowly by consuming gas, stars, and other black holes. But time is the problem. The early universe was not old enough for every giant black hole to grow through ordinary methods. Something may have started the process with a larger beginning, a heavier seed, a shortcut written into the first chapters of cosmic history. And this is where black hole stars become fascinating. They may have been the bridge between the first stars and the first supermassive black holes, not because they were ordinary stars, but because they were something completely different. Imagine a star millions of times more massive than the sun, not a giant like the red supergiants we see today, something beyond modern imagination. A star so enormous that its own gravity was constantly trying to crush it. Inside this object, the rules of normal stellar life would begin to break down. The star would not simply burn fuel and shine. It would become a battle between collapse and survival. Gravity would pull everything inward. Radiation from the trapped energy would push outward. The black hole growing at its center would add another force to this cosmic struggle. Every second, the heart of the star would become more powerful. Every second, the star would move closer to its own destruction. But the destruction would not be immediate. For millions of years, this strange object could exist as one of the brightest and most extreme things in the universe. A star powered by two opposing monsters, one trying to consume, one trying to survive. The black hole would not behave like a vacuum cleaner. That is one of the biggest misconceptions about black holes. It would not instantly swallow the entire star around it. Matter cannot simply disappear into a black hole without consequences. Instead, gas would form a massive accretion flow around the hidden object. As material spiraled inward, it would heat up dramatically. Friction, magnetic fields, and violent motion would transform falling gas into intense radiation. The hidden black hole would become an engine, a tiny region controlling an object larger than imagination. The more it fed, the more energy it released, and that energy would push back. The black hole would be eating the star, while the star's own radiation fought against the feeding process, a balance more extreme than anything in the modern universe. This is why black hole stars are so fascinating. They are not simply stars with black holes inside. They are experiments performed by nature. They test what happens when the two most powerful ideas in astrophysics collide, the birth of stars and the growth of black holes. Eventually, however, the balance would fail. The black hole would continue growing. The surrounding star would become less stable. The object that once protected itself through pressure and radiation would slowly become dominated by the thing inside it. The parasite would consume the host, and the final result would be a much larger black hole. But that final black hole would carry something incredibly important, a head start. Instead of beginning with a small stellar remnant, the universe could begin with a massive black hole seed. That seed could settle into the center of a young galaxy. Gas could fall toward it. Stars could orbit around it. Other black holes could merge with it. Over hundreds of millions of years, it could become the monster we observe today. A black hole millions or billions of times heavier than the sun. This may help explain one of the greatest mysteries in modern cosmology. When astronomers look deep into the universe, they see extremely ancient quasars powered by enormous black holes. Some existed when the universe was only a fraction of its current age. Their existence tells us something important. The universe was building giants almost immediately, but the method remains uncertain. Maybe black hole stars existed. Maybe direct collapse created massive black hole seeds from enormous gas clouds. Maybe several processes work together. Science does not yet have the final answer, and that uncertainty is exactly what makes the search exciting. Because the early universe was a place unlike anything around us today. The chemistry was different, the environment was different, the first stars were different, the first galaxies were different, and perhaps the first monsters were different too. The black hole stars, if they existed, would have lived during a short cosmic window. A time when the universe was young enough to create enormous structures, but violent enough to destroy them almost immediately. They would have been giants that existed briefly and vanished completely. No surviving examples, no surface to visit, no photograph of their bodies, only clues left behind in the black holes that came after. But there is another mystery. How could we ever find something that disappeared billions of years ago? The answer is written in light. When we look farther into space, we look deeper into the past. The most distant galaxies are not showing us the universe today. They are showing us the universe when it was young. The James Webb Space Telescope and future observatories are searching this ancient universe for unusual objects that could reveal how the first black holes formed. Scientists are looking for signs of massive early black holes, strange galaxies, unexpected brightness, objects that appear too massive or too energetic for their age. Each discovery is another clue, because the universe leaves fingerprints, even when the original object is gone. This is the same way we understand ancient stars. We do not need to see the first stars directly to know they existed. We study the elements they created. We study the light they left behind. We study the galaxies they helped shape. The same may be true for black hole stars. Their bodies may have disappeared, but their descendants may still exist. Every supermassive black hole at the center of a galaxy carries a history of feeding, merging, growing, changing. And perhaps somewhere in that history, there was a forgotten ancestor unlike anything we see today. A star that was too large to be normal. A star that carried darkness inside its heart. A star that lived between two identities. Not fully a star, not fully a black hole. Something in between. A cosmic transition. And perhaps that is the most beautiful part of the story. The universe does not always move from one category to another. Sometimes the most important discoveries exist between the boundaries. A neutron star exists between a star and a black hole. A black hole star may have existed between a star and a galaxy. A collapsing cloud exists between chaos and structure. The universe creates complexity by passing through strange intermediate stages. And black hole stars may have been one of those forgotten stages. A brief moment when the first giants were born. A moment when a star carried a monster inside. A moment that may have shaped the entire future of the cosmos, because the galaxies we see today may not have begun with ordinary stars. They may have begun with impossible ones, stars that were never meant to survive, stars that became something else, stars that died so completely that they became the seeds of the largest objects in existence. And somewhere hidden in the darkness between galaxies, there may still be clues waiting. Not telling us only how black holes were born, but telling us how the universe learned to build. What feels more incredible to you? That the universe may have created stars larger than anything we see today, or that the darkest objects in existence may have been born from the death of those stars? Subscribe to explore more mysteries through the questions that still lead humanity to the edge of reality.